How did you go? Did you manage to get the exercise out? Let's have a look at the solution. Here is my solution. I've called it children.c, and you can find it in the Chapter 2 part of your CD. Let's go through it, shall we? Firstly, we have the stdio.h. As I said, that should be included at the beginning of every C program that uses the printf or scanf or fflush or getchar. It should be there. It's better to have it there than to not have it there. Then, of course, we have the main with the brackets. We have now two variables, each on its own line, both of them integers. First one called brosys, which have called it brosys, short for brothers and sisters, because I didn't want to type out brothers and sisters. And the second one called children. Now, the first four lines of the program are quite straightforward. A printf, how many brothers and sisters do you have? There's no \n there because we don't need it. The scanf of one number, a %d, with the ampersands. Remember, we need the ampersand, and then the first variable, and then exactly the same again for the number of children. And now we come to the hard part of the program, getting them both printed out on the same line. And this is how I've done it. You have %d brothers and sisters and %d children. And then a comma, and then this. Now, I know that this is actually appearing on the next line here in the source code, but that's only because my window isn't wide enough for it all to be displayed on the same line. So I've just wrapped it around onto the next line. You can do that, by the way. We'll talk more about that in the next chapter. However, just for the moment, pretend that those two are out actually on the end of the previous line. So, we've got a %d brothers and sisters and a %d children. We have two %ds and we have two variables. Two variables at the end, both separated by commas. What happens here is simple substitution. The value in brosys is put into that %d, while the value in children is put into that %d. And if there were three %ds, then you'd need a third variable here. That's as simple as that. You could even have 10 or even 20 %ds on the line, and it would still work, although it would perhaps be a little bit cumbersome. And then after that, we've got the fflush and the getchar, and everything is as before. Let's see if that works, shall we? We'll compile it. 0 errors, excellent. Now we'll try and run it. How many brothers and sisters do you have? Let's say 2. How many children do you have? 3. And let's see what happens. You have 2 brothers and sisters and 3 children. Well, that's working. I'll press enter to close the program. So what happens in scanf when you don't enter a number? If you just enter letters, shall we say? Well, let's try and find out. Run the project again. How many sisters and brothers do you have? Type in the word Fred. Ooh, that's very odd. It's asked the second question, but it hasn't bothered to wait for an answer, and then it's already printed out the answer to everything. You have 575 brothers and sisters and 65,535 children. Well, that sounds a little bizarre. You'd think that the program could behave a little bit better than that. Now, this is a function of scanf. Scanf is not the most user-friendly program to use, and for that reason we tend to not use it very often. It is okay for basic programs, but in this sort of incidence, when the user of your program can accidentally type in something wrong, and then the whole program goes haywire, is one of the reasons we don't use scanf terribly much. Printf, however, is used extensively. Scanf, not so much. And if you take the ampersand away, and I'm talking about the ampersand here, and or the ampersand here, and then try and run the program, I don't want to do that because it will probably crash my system, and I'm unwilling to take that chance. How did you go? Did it work for you? I know it wouldn't have worked, but did it crash, or did it do something else? Finally, let's look at the largest number that you could enter. Well, if you've done a little experimentation, you'll find out that the answer is in fact the following. It's 2,147,483,647. Of course, you were just going to say that, right? Why is it that, of all things? Why not something else? Well, that number happens to be 2 to the power of 31 minus 1. So that's 2 times 2 times 2 times 2 times 2 times 2, 31 of those, and then subtract 1 from the answer. Can you think why? Have a think about that for a second. Well, it has to do with 32-bit numbers. In fact, it may be that in your compiler, that's not the answer that you get, that the largest number is not that. You might find the answer on your system is, I think it's 32,267 from memory, which is 2 to the power of 15 minus 1. It all has to do with the size of the integer on your computer. Some computers have 32-bit integers, some computers have 16-bit integers, and it all depends. On a 32-bit system, it's usually 2 to the power of 31 minus 1. That's a little bit mysterious at the moment, but as you develop a greater understanding of your machine architecture, you will understand that. Anyway, for now, you can just notice that there is actually a limitation, an upper limitation on the numbers that you can enter when you're prompted for an integer number.